So hello guys, today we are going to do a LeetCode question that goes by the name length of longest subarray with atmost k frequency. The question number is 2958 and it's a LeetCode daily question that is for today, that is 28 March 2024. Okay, what is the title saying? Length of longest subarray with atmost k frequency. Okay, is the title giving some information about the question, like what we have to do? Yes. Okay, what the title is saying? Length of longest subarray. Okay, we have to find something like longest subarray. And what is the condition of finding that longest subarray? You will have to have the subarray must have a frequency of k, at most a frequency of k. Okay, so let us first try to read the problem statement and then we'll go into the solution. Okay, that's how we do it here. We first try to go to the problem statement and then we'll try to analyze what are the things that we need to solve this question, because you can't solve this question as a whole. Okay, you have to break it into parts and then only you can solve it. Okay, then only you can solve it. Okay, so what if I just try to read the problem statement? What is the problem statement? You are given an integer array nums and an integer k. Okay, you are given an integer array nums and an integer k. The frequency of an element x is the number of times it occurs in an array. Okay, so what is the frequency of an element? What is the frequency defined as? Frequency of an element x is the number of times that element is existing in the array. That element is existing in the array or string or anything. Okay, or linked list, anything. Okay, so frequency is basically number of times a particular character, a particular element, it's existing in the array. Okay, okay, so array is called good if the frequency of each element is less than equal to k. Okay, so I will be given an array and I'll have to find a subarray such that all the elements have a frequency of atmost k, have a frequency of atmost k. Okay, atmost k. So it will have a frequency of atmost k. Okay, return the length of longest subarray of nums, and you have to return the longest good subarray. You have to return the longest good subarray. So this is my subarray, this is my definition of good subarray, and I have to return the longest length among it. Okay, longest length. A subarray is a continuous non-empty sequence of elements within an array, that we know. Okay, subarray is basically like if you are given with something like this 1 2 3. What are the subarrays? Possible? 1 2 is a subarray, 1 3 is a subarray, sorry, 2 3 is a subarray, 1 is a subarray, 2 is a subarray, 3 is a subarray. What is not a subarray is basically 1 and 3. 1 and 3 is not a subarray. Okay, 2 and 1 is not a subarray, these are subsequences. Okay, subsequences, and 2 and 1 is also not a subsequence. Okay, so just removing this is a subsequence. Okay, okay, so what if I just try to jot down the problem statement, I just try to divide it, what the question is trying to say. I'll have to find subarrays, I'll have to find good subarrays, and what is my definition of good? Definition of good is basically all the elements should be existing at most k time. Elements frequency should be less than equal to k. All the elements frequency should be less than equal to k. So this is what you are given. Find the good subarray such that all the elements frequency is less than equal to k. Okay, okay, okay. And good all the elements of frequency less than equal to k. Okay, okay. So how can I know about the frequency? And I have to find the longest of them. Okay. How I'll have to find the frequency? For finding the frequency of an element, what is the best data structure that we can use? Yes, unordered map. So unordered map will do the work of storing the frequencies of each character or an element with its frequency. It will store the element with its frequency. Okay, and then we can find all the good subarrays, and we have to find the longest of them. How we'll do it? Okay, how we will do it? Okay, if I just try to get a simple answer like 1 2 2, 4, 1, 4, 6, 7, 8. Okay, this is the subarray that I am given. Okay, these are the array that I am given. Okay, first I'll tell you what are how to make the subarrays. How to make the subarrays, like basically 1, 2, 3. It will consist of all the contiguous part. Basically, starting at this index, how many subarrays it can form? 1, 1, 2, 3, 1, 2. Okay, so basically what you have to do is you have to stand at one element and consider the element as well as all the elements that are occurring before it. So all the elements would form, one subarrays, one subarrays, and we have to do this for all the elements, like starting at this position, then going to this position, and then doing all this, then doing all this. I just hope that you know about this. Okay, if you don't know, you can watch our previous subarrays videos. You will get to know it. Okay, so or I'll try the example that is given. Okay, 1, 2, 3, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3, 1, 2. Okay, 1, 2, 3, 1, 2, 3, 1, 2. Okay, so what I have to find is I have to find a subarray such that all the elements have a frequency less than equal to 2. All the elements have a frequency less than equal to 2. Okay, I'll make a map. I'll make a map. What can be my brute force approach? What can be my brute force approach? Brute force approach can be I can just check all the subarrays. I can check all the subarrays. Check all the subarrays. Okay, check all the subarrays. Basically, if I just stand at this element, then all the subarrays would be like starting at 1, then first this will be the subarray, then 1, 2 will be the subarray, then 1, 2, 3 will be the subarray, 1, 2, 3, 1 will be the subarray, 1, 2, 3, 1, 2 will be the subarray, and so on. Okay, and so on. So you will check all the subarrays, and for each subarray you will just iterate the map. You will just iterate the map to check if all the elements have a frequency of less than equal to 2. If all the elements have a frequency of less than equal to 2, if it is following this condition, you have to update your maximum length. You have to update your max length. Okay, the max length will be set to initially 0 because we are assuming that there is no subarray present. Okay, so the minimum length would be 0. It cannot be negative, as length cannot be negative. Consisting of elements, it cannot be negative. Okay, so what I'll do is I'll check all the subarrays. And for each subarray I'll simply check whether it is following the good condition. Whether it is following the good condition, that is all the elements are occurring less than equal to k times. All the elements are occurring less than equal to k times. Okay, all the elements are occurring less than equal to k times. So all the elements are occurring less than equal to k times. So if it is following the condition, I'll just update my max length. Check all the subarrays. So these are the steps. Check all the subarrays. Okay, and how will I make the subarrays? Basically using the n square approach, starting at this position, then checking for all. Okay, so it will be like check for all the subarrays, and in each subarray, just check if all the elements just check if all the elements have a frequency of less than equal to k, and if it is following the condition, if it is following this condition, then just update the max length. Okay, so this is my algo. This is basic algo. These are the steps that I'll perform for the brute force approach. I'll not run it. We'll just try to move to the optimal solution. Okay, I'll attach the code below for this. Okay, but it will have a time complexity. If I just try to analyze the time complexity, I'll have to check for all the subarrays. So generating the subarrays would itself take O of n square, and checking for the elements, whether the frequency is less than or equal to k would take another n. Okay, so it will be O of n cube. And what is the space complexity? Space complexity would be O of n, because we are using a map. Auxiliary map. Basically for every case it would be created. Okay, so O of n cube. Okay, will O of n cube work? Let me see the constraint. 10 raised to power 5. So 10 raised to power 5 raised to power 3. It will be 10 raised to power 15. Bro. It can't work at any case. Can't work in any case. Okay. It can't work in any case. Okay, it can't work in any case. Okay, so what I'll do is I'll simply now go to the optimal solution. Okay, what are the things that would remain fixed? I would have to look for all the subarrays. I will have to look for all the subarrays, and I should have a frequency map. And I'll store all the all the max length. I'll just update. Initially, it will be 0. Okay, the frequency map is needed and all the sub arrays. So what is the thing that I can optimize? I cannot optimize this. Because frequency map is something I need. I cannot optimize this. Like basically, this is not taking any time, but the frequency map is taking off n time, and this is taking off n square. So what is the thing that I have to just optimize? I cannot optimize this. This would take off n square. But if I just try to optimize this sub-array part, if I can just get it in O of n, okay, O of n, and basically if I can just do the operation simultaneously such that it takes O of 1, or something like O of n plus n, I can make it work. Because O of n plus n means 2 into 10 raised to power 5. So that would work in any case. Okay, in this case, basically. So creating the subarrays, I'll have to just optimize this. Okay. So what are the things that can be used to create the subarrays? Basically, I have to check for the subarrays, right? So basically, for the subarray case, you'll just observe that the 2 pointers and sliding window approaches are used. Because we can just iterate once and move the pointers such that we can get access to every subarray. Okay, in this question also we will just use a sliding window. Plus 2 pointers approach. Okay, so I'll have to generate all the subarrays using the 2 pointers and sliding window approach. How will I do it? And how I got to know? Because I had to optimize the subarray part, right? If I have to optimize this, I'll have to think of the 2 pointer subarray approach, 2 pointer sliding window approach. Okay, either this or hash maps are used, commonly. Okay, to for the subarrays for seeing the subarrays, but hash maps will not be acceptable in this because it is not like I have to find any similarity or something. I have to just look for the frequencies. So 2 pointer sliding window is a better approach. Okay, so how will I do it? I'll just take this example 1 2 3 1 2 3 1 2. Okay, I'll just simply dry run it. Okay, and you will get to know about it what I have to do. 1 2 3 1 2 3 1 2. Okay, this is my array. What I'll do is I'll simply put a pointer here, and I'll simply put a pointer j here. Okay, I pointer here and j pointer here. Okay, what I'll do is if you'll see, if I just consider this single element, this is also considering a subarray. Okay, this is also considered as a subarray. Okay, so I'll make a map as I need a map. Okay, and I need that the frequencies of all the elements in my subarray should be less than or equal to k. Okay, and my max length is equal to 0 initially. I'll update this max length as soon as I get any answer. So I'll come to this element. I'll move my j pointer. Remember, I'll move my j pointer if the condition follows, and if the condition doesn't follow, then I have to move my I pointer to a point till when my condition follows. I'll just try to explain you. I'm moving my j pointer. I'll move my j pointer first. Okay, till it is following my condition. Okay. So for the first element, if I just try to store it in my map, if I just come to the first element and try to store it in my map, is it present in my map already? No, so I'll store it. So 1 would be stored with the frequency of 1. Okay, I'll just move forward. Is it following the, and after storing, just store and check if it is following the condition. Okay, because I'll have two cases. Either I'll move the j pointer or I'll have to move the I pointer. So I'll have to check for the cases. Okay, in which I have to move the j pointer, in which I have to move the I pointer. Okay, as I've just stored the element, I'll check whether the frequency is less than equal to 2, because it is k is equal to 2 in this case. Okay, less than equal to 2, yes. Okay, I'll move to this element. Okay, I'll just store it. As it is not already stored, I'll just store it. Okay, and just then I'll check whether it has a frequency of less than equal to 2, whether all the elements have a frequency of less than equal to 2. Yes. Okay, I'll just move forward. I'll store 3. Are all the elements having a frequency of less than equal to 2? Yes. Okay, my j comes here. Okay, I'll update my I. Okay, are all the elements are still having a frequency less than equal to 2? Yes. I'll move forward. I'll increase the frequency of 2. Are all the elements having a frequency less than equal to 2? Yes. Okay, I'll still move forward. My j comes here. I'll increase the frequency. I'll still check whether all the elements have having a frequency less than equal to 2. Yes. Okay. Now I'll come to this point. And I'll again update my one's frequency. So are all the frequencies less than equal to 2? No. My one's frequency is just disrupting my answer. Okay. So what I'll do is now I'll move the I pointer, because I cannot move the j pointer forward, because if I move the j pointer, the frequencies are gonna increase. So I have to reduce this frequency. Whenever I see that the frequency has increased of a particular element, I'll try to just reduce this frequency. So I'll move the I pointer till a point comes that the frequency becomes less. Okay. So I'll move my I pointer, and before moving, I'll just reduce the current element's frequency. So this is the element 1, and I'll reduce its frequency will become 2. Okay, I'll move my I pointer. My I comes here. Okay, are all the frequencies less than equal to 2? Yes. So can I move my j now? Yes, you can move. Okay, so my j comes here. My j comes at this place. Okay, I'll increase my 2's frequency. Okay, are all the frequencies less than equal to 2? No. So what I have to do? Yes, I'll have to increase my, see, it is simple. If the condition is following, just increase your j pointer. Because you have to increase your range. Or if the condition is failing, just increase your I pointer. Okay. Just increase your I pointer, and at the last increase your j pointer. Why increasing this j pointer? Because if you don't increase this j pointer, this j would be calculated again. I'll just show you. Okay. So as I can see, the frequency of 2 has become greater than equal to 2. Okay, greater than 2. So what I'll do is I'll just update my I. I'll just move my I forward, but before moving, I'll just decrease the frequency of 2. I'll just decrease the frequency because the 2 was the current element. Okay, my element is now here. Okay, element is now here. And I just forgot to mention about the thing that the condition was being followed to this place. So what will be my maximum length? 0, 1, 2, 3, 4, 5. So maximum length would be 5. Okay, maximum length would be 5. Is it going to be 5? No, 6 elements are there. So 5 plus 1. Basically j minus I plus 1. So the length would be 6. Okay. I'll still move forward. As I can see that it is following my condition. I'll move my j. So my j would be coming here. Okay, my j would be coming. As you can see, the loop will end at this place because the j pointer has moved forward and it cannot access the element. Okay, but still, as you can see that there are some discrepancies. There are some elements yet to be inspected. So I'll just add an edge case. This is an edge case that if the j pointer has just increased, if the j pointer has increased, I'll just simply update my maximum once again. And what it will be, max of mx comma j minus I plus 1. Okay, so it is gonna be my answer. Okay, what is gonna be my answer? As my updated mx was last 6, so 6 is gonna be my answer for this case. Okay, what I'm doing nothing. Simply, basically, I am moving my j pointer. If the conditions are being followed, if the condition is being followed, I'll move my j pointer, and if the condition is not being followed, I'll move my I pointer. Till a point till a point that my condition follows. Till my condition follows. Okay. Okay, so moving the j pointer and moving the I pointer would give us the solution. Okay, moving the j pointer and moving the I pointer will give it the solution. Would give us the solution. Okay, so what I'll try to do is I'll try to run one more test case and then tell you maybe you get a better understanding. So I'll take this example 1 to 1, 2 1 2, 1 to 1, 2 1 2, 1 2, 1 2 1, 2 1 2, 1 2. Okay, this is my array. This is my array. 1 2 3 4 5 6 7. Okay, this is my array and my k is equal to 1. K is equal to 1. That is, my sub array can have at most k elements, at most k occurrences of each element, at most k occurrences of each element. I'll make a map. I'll make a map that will store my frequencies and I'll try to do the dry run. Okay, my j pointer is here and my I pointer is here. What was my conditions is, when my condition is being followed, that is the elements are less than equal to k, what I'll do is I'll simply update my maximum. I'll simply update my maximum update, and I'll move my j pointer. And when the condition is not being followed, that is the elements occurrences are greater than k, that is that particular element's occurrence is greater than k, then I'll reduce it. I'll just increment my I pointer till the occurrences of that particular element, becomes less than equal to k. That particular element becomes less than equal to k. What I mean by this, just see. Okay, I'll tell you. My j pointer is here. Okay, I'll move the j pointer. It is following the condition. I'm just moving into my map. What I'll do is I'll just store and then check if it is following the conditions. Okay, what I'll do is I'll simply move it to my map. Okay, 1 is occurring one time. Is it following the condition? Yes, 1 is occurring one time. My j pointer moves here. I come to 2. Is 2 occurring one time? Yes. Okay, is all the elements occurring less than equal to one time? Yes. I'll move my j pointer. My j pointer comes here. Okay, I'll increase my occurrence to 2. 1's occurrence to 2. Okay, are they following the condition? No. So what I have to do? I have to decrease the occurrence of 1. And I have to increase my I pointer. Till a point comes when my elements are following the condition. So I'll increment the I pointer, but before incrementing, I'll just decrement the frequency. So 2 minus 1 is equal to 1. 2 minus 1 equal to 1, and I'll increment my pointer. Are they following the condition? Yes. Are they following the condition? Yes. And alongside, my max would be updated, so my max would be 2. Why 2? Because these both elements were following the condition. So max 2 is there. Okay. Now I'll move to this element. I'll move to the next element. See, if after incrementing the I, I don't increment my j, so that j will be counted again. Okay, so this I don't want. So I'll increment my j. My j comes here. I'll increase my 2's frequency. Are they following the condition? No. So what I'll do is I'll increment my I pointer, but before incrementing, I'll decrement the frequency. So 2's frequency becomes 1 and my I is incremented. Are they following the condition? Yes. Okay, but my max is still not updated. It is still 2. Okay, I'll try to go to the next element. I'll increase the frequency. 2. Are they following the condition? No. So I'll again increase. My one's frequency becomes again 1, and j comes at the next element. Okay, now this element is being taken in consideration. So this becomes 2. Is this element following the condition? No. Okay, so this will be reduced. And I pointer would move here. Okay, I'll increment my j pointer. My 1 would become 2. Is 2 less than equal to 1? No. So I'll just try to decrement it. My j pointer would now come here. I'll still again increase my occurrence. Okay, are they following the condition? No. So my I pointer would increase and my occurrences would reduce. Okay, and my j pointer would increase. So my j pointer, when it comes here, I'll stop. Once it comes here, I'll stop. Okay. So this is my ending condition. So till when I'll run a loop? j is less than n and I is less than n. These are my ending conditions. Okay, if you can see, the answer is 2 in this case. And for similarly, k is equal to 4, this same operation can be done on this also. Okay, if I just try to consider a test case with less number of 5s, okay, I'll just take 5 maybe. Okay, or I'll take the same test case 6 7 5s. Okay, 1 2 3 4 5 6 7. Okay, this is my map, and this is my map, and this is my array, and these are my pointers. J pointer here, I pointer here. Okay, k is equal to 4. K is equal to 4. So what I'll do is I'll increase the frequency. My 5 becomes 1. Okay, are they following? Is it following the condition? Yes. I'll come to this element. I'll still increase my still increase my frequency. Is it following the condition? Yes. I'll still increase my frequency. Is it following the condition? Yes. I'll still increase the frequency. Is it following the condition? Yes. So my max would still become, max would become 4. Max would also become 4, because if it is following the condition, that then I have to update my max value. Okay. Then I have to update my max value. J pointer comes here. Is it following the condition? It has become 5, so I have to reduce this frequency. For reducing the frequency, I'll increment my I pointer. So my I pointer would be incremented and this frequency would be reduced. So 5 frequency is reduced by 1, so it becomes 4. Is it following the condition? Yes. So my J pointer is incremented. J pointer will be incremented. Okay, my J pointer would come here. The frequency will be incremented. Is it following the condition? No. Okay, my I pointer would increase. It would decrease. J pointer would increment. I'll again increment, and I becomes here, I comes here. Okay, and it becomes 4, and in the next case the j becomes here. So this is my ending condition. This is my ending condition. What is my max value? My max value is equal to 4. Yes, this is what I have to return. I just try to write the code for this test case, this question. Okay, just observe. Okay, what I need is, I need 2 pointers, and I'll initialize them to 0. I'll also mark the size of the vector that I have to iterate. I'll also mark the size of the vector that I have to iterate, and I'll continue. What are my ending cases? These are my ending cases. I'll continue till my j is less than n and I is less than n. Okay, my k is already given. K is already given. Okay, and what I need is, for the frequencies, what I need is unordered map. Unordered map that will store my element and the frequency. Okay, so MPP of nums of I plus plus. Okay, this I have to do for all the cases. This I have to do for all the cases, and I have to check. Whether the nums of j plus plus, and whether I have to check whether it is less than equal to k. And if it is less than equal to k, what I have to do, I'll increment my j pointer, and alongside, basically incrementing the j pointer means increasing our length. This is increasing our length. J pointer is increasing our length, and when it reaches a particular position, when it is not following the condition, I'll decrease my I pointer. So as you can see, it will take all the subarrays in consideration if we just try to observe. Okay, and what I need is, I need a max value also that will be updated, that will be storing the maximum length, and it will initialize to 0. Okay, and for every valid case, this value would be updated. So it would be maximum of mx comma j minus I plus 1. Okay, else while my nums of j, while my MPP of nums of j becomes remains greater than k and I less than equal to j, what I'll do is I'll simply decrement my I values, and if it becomes 0, what I want is, I want that it should be removed from the map. Okay, and my I pointer should be incremented, and if I have to check a case if my MP of nums of j is still less than equal to k. If this is the case, my mx would still be updated. Okay, and I have to increment my j pointer. What I have to return? I'll have to return the mx value. 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 Okay, so I'll try to run it. Okay, I'll try to submit. Okay, ran successfully. So I'll just try to explain you the code. What I need is, I need an unordered map. I need an unordered map for storing the frequencies. I need an unordered map for storing the frequencies, and till what I have to run, till what condition I have to run. I have to run a loop till my j and I pointer less than my range. Okay, and what I'll do is I will increment for each occurrence. I'll increment for each occurrence of j. Okay, I am if I am increasing my range, I want that this element that is being increased, that is being included, this is stored in the map. This is stored in the map, and if the frequency is less than equal to k, then update the maximum because it is following the condition. Because it is following the conditions. Okay, and I increment my j pointer. If the map is not following the conditions, I will, if the map is not following the condition, that is the element's frequency, the element that is included right now, just right now, has a frequency greater, has a frequency greater than k, then what I'll do is I'll simply increment my I pointer. As suppose this j element is not the valid element. What I'll do is, if I have to remove its frequency, I have to reduce its frequency, right? I have to reduce the j pointer frequency. So I'll increase my I pointer till it comes at a point that my j's frequency is reduced. That's why I just written mpp of nums of j here, because this is what I have to monitor. Okay, and my I pointer would be increased. Okay, like I pointer would be increased, and if any of the frequency, suppose j is coming here, I is coming here, and in between some element frequency becomes zero. Okay, because if I am increasing my j, if some element frequency becomes zero, then I have to remove it from the map. Like there is no use of that element, right? So I'll just remove it from my map. Okay, I'll implement my I pointer. And why I added this here? Because I just shown you the case. Because my j would be stuck here. If my j would be stuck here, and if my I is incremented, this can also be the valid array. So before incrementing my j pointer's value, I'll check whether this range is valid or not. So this is my edge case. Okay, this is my edge case. That I have to handle. Okay, this is my edge case. Basically when after increasing the I pointer, there can be still a minimum value, still a possible subarray. So I'll just check the length. Maybe it is greater. Okay, so I'll just take it and increment my j pointer, and at the last I return my max. Okay, so if I just try to see the time complexity of this, basically I'm just iterating once using the j pointer. And suppose if I just iterate fully due to my I pointer also, so it will become O of n plus n. Because suppose if my j is stopping here at the last position, this is my last position, my j is stopping here, and my I is at the starting position. So I will have to come up to here, because if the condition is not yet fulfilled, it has to travel again. So it becomes O of n plus n. And what is my space complexity? My space complexity is O of n, because I am using an unordered map to store the frequencies. So this was the solution to the question, length of the longest subarray with atmost k frequency. Okay, I hope you guys like the solution. If you have any doubts regarding the question, regarding the solution, okay, then just ping it out in the comments. If you like the solution, do like, share, subscribe. Thank you. Have a nice day.